Hello friends, let's discuss about the cancellation of the order. So as we have discussed before, this part, all the price levels are actually a priority queue, and each of the order nodes that we have for each price level, for example, say we have got 20.3 as our price level. So for that, we have got a doubly linked list in which represents each orders at that particular price level. For example, we can see that we have got 3 orders in our doubly linked list, each having a link to each other. And this is the head. As per the time, you can see, right, the highest priority is having the best time. It was the earliest. So 901 order 1 is the earliest, and then 905 and 9015. So based on price time priority, this is our order list. Now suppose I have to cancel this particular order, right? So we got a cancellation of order. Now from the cache, we have where we maintain our in a hash map order ID key as a key, and then we can get this order. And this order is actually maintained in a doubly linked list, right? So suppose I want to cancel this order. So what I need to do is that it can be done in O1 operation. What we need to do is that we just need to update the links of the order 1 that they should point. So this link which is going here, right? This should remove this link to order 2 and move directly from here to the next order, right? And similarly, for the order 3, we need to just update the previous link. So this link should be changed from order 2 and it should directly go to order 1. Just updating these 2 links, we are able to remove this order 2 from our order list. And this is an O1 operation. Similarly, if we have got the tail order to remove, to cancel, or order at the head that we want to cancel, we just need to update the previous or the next link. So for example, for order 3, if you want to cancel it, we just need to update this pointer for order 2, right? We need to just update it to null. That's it. Once you point it to null, then it's all. Then order 3 is already having no link in this order list and it's ready for the garbage collection. Similarly, if you want to remove the head, so all you need to do is that order 2 will become the new head, which means that at this price level, the head will point from order 1 to order 2. That's it. So this is where we can remove any order at the head. There is one more here where we have only like one order in our price list at our price level in this scenario. So in this case, because we don't have any other orders in this order list, if we remove this, so we have to remove this complete price level. So remove this complete price level because we are maintaining this all these price levels as a priority queue. So in this case, we will have to have O of log n of time complexity to remove the complete price level. So these are the only two scenarios possible for canceling an order. One in which there are more than one orders, in which we need to just update the links here of the previous and the next node. And if we have only one order to cancel from a price level, so after removing this order, we have to also completely remove this price level from this priority queue. So the same has been depicted in the code. What I just explained in the diagram. The same has. Let's go to the code now. So the cancel order. First of all, this is our order, which is a hash map by which we get the actual order from the order ID, and then we remove it. Go to the remove order. Now for the remove order, first of all, we will remove it from our hash map. After that, we will check what is the side, because we are maintaining 2 separate type of priority queues for price levels. So what I want to say is that here we have got this price levels for sell and price level for buy. Both are different priority queues. So let's go for the remove order here. So it will go to this price levels and order because we are giving the price level, which is a priority queue. Now, first of all, we get the price, which is a double. For example, if you want to remove a particular price level at that price, we'll get that price first. And from that price, we are going to get our order list, which is a linked list. Please note that this order set price is a hash map, which contains the price level and the order list associated with that particular price level. So what it means is that this hash map is having this key as a key, and then the value is the doubly linked list of all the orders. So this is a line where we actually remove the order from our doubly linked list, which I explained in the previous diagram. This is where we are updating the links in case of more than one orders, and we just need to update the previous and the next node. Okay. So let's look. go at this actual method. So now we are inside this in our order list, which is the DoublyLinkedList. And here we have taken case of all the scenarios, whether it's empty or whether it's in the middle of the link and all. So this is the main method, remove node. I mean, I will not go through the details, but you can, I will share the code base so that you can go through it. But the design is exactly same as we just discussed in the diagram. So here, if we check that if the node is the head, in that case, we just point the next head, which is the next node in our head. For example, we just need to, if we are trying to remove this order 1, we only need to make this order 2 as a new head, and this would be automatically garbage collected. Similarly, the tail is also discussed as we discussed in the diagram, that if the tail, then the previous will just update its next link to null. That's it. Tail.next is null. That's it. And this is how it will remove. And if the node is in the middle, we already discussed that the previous node will and the next node link would be updated accordingly. For example, here we discussed that if we want to remove this order 2, then we need to update the next link of order 1 and the previous link node of order 3. So this is the whole code doing all this logic. Now, whether it's only one node present or not, or multiple nodes present, multiple orders present in the price level, we discussed that if there's only one price level, one order node left, then we also have to remove the complete price level for that particular node. Now, this is the block where we discussed that if there's only one node there, for example, here we are talking about this particular level. If there's only one node available, one node there to cancel, we need to cancel this and also remove the whole price level. So this is what it here. If order price level after the removal is empty, in that case, first of all, we need to update our hash map where we have got this price link, price as a key, and the DoublyLinkedList as the value. We need to remove it from there. And after that, this is our price levels. This price level is our priority queue for that sell order. In that case, also we have to remove this price, which is O of log n of because it actually uses a heap. So that's why it's O log n. So the overall complexity, we can see that it's only O1 if there is if this is a scenario that we are only removing, there are multiple order nodes and we are removing one of the orders via cancel method. So the time complexity would be only O1. And if we are using this order 1, as we discussed that removal of this order node would be only O1, but the removal of the price level from this priority queue would be O of log n. So the worst time place complexity for our whole logic for cancellation would be, in the worst case, would be O of log n, which is much more better improvement as our previous design where we're only maintaining a priority queue or a DoublyLinkedList. Okay, so this was all about the cancellation of the order. I will share the code base. And in the next video, we'll cover about the amendment of orders. So see you in the next video.